Okay, welcome to the first Python tutorial seminar. In this seminar series, we will meet the second and fourth Wednesdays of each month at 1 p.m. Mountain Time, as we are right now, to cover various Python topics as we build our toolkits and skills. The first seminar series will span 3 sessions and we'll be creating our first Python script. Today, we're going to read in a .text file and take a look at our sample atmospheric data as we learn some basic Python commands. But by the end of the third session of 4 weeks from now, we will use that same sample data to calculate the wind chill index. The target audience of these seminars are scientists who are already familiar with some programming language, already have some experience, but perhaps in a language other than Python. A lot of you already use NCL, IDL, or MATLAB, so we don't have to go too in-depth in topics that are much the same between these 4 high-level interpreted languages. High-level meaning that a lot of commonly used functions and data structures have been provided for you, obscuring the nitty-gritty of things such as memory use and other information related to performance. And interpreted meaning that you don't have to worry about compiling your code and that your code is portable and compatible across machines. So this is a lot easier for you, but likely a little slower, more memory intensive, and generally less performant than some other languages. One of the things that makes Python so unique is that it is open source. This means that if you have a coding problem, likely someone else has already tackled it and posted their code for others to use. And this is really great because then we reduce the amount of redundant work across between scientists, and you can focus more on the actual science that you want to do. But as tools can evolve with the needs of the user base, there are a few extra challenges. Perhaps you write a workflow that uses a certain set of tools, but over the course of the year, the original author of some of those tools has added new fancy features that potentially break some things in your workflow. So that is why we're going to teach package management with Conda so that you know how to preserve these tools in the state that you used them and that you know will work for your analysis. In the past, our tutorials, like many others, have maybe obscured this package management by providing a set environment for you to install before we begin the tutorial. But we've realized that that often leaves our Python learners out in the cold, not knowing how to manage their environments on their own after the tutorial. And it also tends to confuse people because each package might have its own specific functionality and its own specific syntax. And if you don't introduce them one by one, you can easily mix up what goes with what. So today we will only install Python in our environment and do as much analysis as we can with Python alone. Over time, throughout the seminar series, we'll introduce the most popular, most helpful packages that have tools for scientific analysis. And we'll do this one by one, making sure you're confident before we move forward. So today, pure Python. And with that, some basic Conda and Git. Git being the best practice for saving, organizing, and collaborating on your work. But because each session is only 1 hour, we're going to try to run through everything, but as detailed as possible, and then we can take questions at the end. We chose to do the seminar series instead of a full day virtual tutorial, so that way we have time in between lessons to work with anyone who is confused, had some technical issues to catch you up before the next session. So you can ask any questions you have by posting in the Zoom chat to everybody. And if you're lucky, someone from the Xdev team or a fellow learner can help you out. Otherwise, I personally will not be looking at questions in the chat until the end of the session. And we can also help you out before the 28th. Oh, I did not start the recording yet. I'm sorry. I will do that right now. Let me look for that. Okay, we're starting the recording. Sorry, we missed the introduction, but we have not begun any of the coding yet.
No, Julia, I hit record at the very beginning.
Oh, thank you so much. Perfect. Okay, so now I'm going to switch over to a terminal screen. So this is the first thing that you should do for this session is to open up a terminal window and check that you have installed the requirements for this course, which are Conda and Git. So can everyone see me typing in the terminal? Again, just a thumbs up. Perfect. So we're going to type Conda -- version. And this will check that you have Conda installed. If it fails, it means that you don't have Conda installed. So I have version 4.8.5, which is the most recent. Anything as new as 4.7 should be fine. Just want to also double check that this font is large enough for everybody. Okay. If your version's older than 4.8, you might have to update it if it's particularly old. So you could do conda update n space conda. And we sent this out in the instructions prior to this, so hopefully everyone's up to date. And we're also going to check that we have Git installed, which looks very similar. We do git -- version. You can see I have a version of Git that is through Apple, but you might have a different version, and really anything should work. Now we're going to set up our workspace, now that we know that we have everything we need to set up our workspace. So I'm going to move into my documents folder because right now I'm a little higher up. So I do cd for change directory and the name of the folder I want to go into. And now that I'm here, I'm going to create a new directory to store everything for this tutorial, both this session, and we can use the same directory over the course of the seminar series. So I type mkdir for make directory, and I'm going to name it Python_tutorial. You could name it something else. Perhaps this name is already taken from a past tutorial you've done, but if you do, just keep in mind that your code is going to look slightly different from mine moving forward. And then again, I change directory cd into this folder. Okay, now that we've created our folder, we are going to create our Conda environment. So again, your Conda environment is a directory that contains a collection of packages and libraries you'd like installed and accessible for this workflow. So to create this, we type conda create -- name, and then the name of your project, which here I'm going to again name Python_tutorial. And then everything after this, every argument after this is a package that you'd like installed. So I'm going to do space Python. Sorry, I just got logged out of my notes. I'm gonna fix that real quick. Oh, did not get the push. It's the worst thing that could happen right now. It's logging out of Google Notes. But I'm gonna do space Python to install only Python in this environment. And so hopefully I'll fix this while you guys are creating your environment.
Julia, we've had a request to go just a touch slower.
Oh,
Possible?
Yep. Perfect. Perfect timing. Okay, so once you're on this screen, say yes, you'd like to proceed creating your environment. Okay. So it's a good idea to create a new environment for different projects because, again, Python's open source, so new versions of tools that you may use have become available over the course of time, and maybe certain projects use different versions of those tools. So it's a good way of guaranteeing that your script will use the same versions of packages and libraries and should run the same as you expect them to. So now that you have your environment installed, we're going to activate it.
Julia?
Yep.
Can you scroll up just a little bit and show people what the command was to creating the environment? There are apparently some people who are a little. There are some people who are behind.
Thank you. Thanks for watching the chat and catch it. So the command is conda create -- name Python tutorial Python. I'll leave this up for a minute. It is a little extra challenge not being able to look around the room and see people's faces, both elated and concerned, or to just notice when people need help. So thanks for typing in the chat. And I want to shout out to the rest of the Xdev team for monitoring that and making sure that we can help keep everyone as up to speed as possible. Okay, are we ready to move forward? Okay, so I will not enter this command again. Instead, I will enter conda activate and then the name of your environment, which for me is Python_tutorial. And yeah, that's a good point. I'll wait a second before I hit enter every time, just in case the output pushes the command way off the screen for everybody. Okay, I'm gonna hit enter. And maybe you've noticed now that on the left side of the commands, it tells me where I am. So before I was in my base environment in conda, and now I'm in Python tutorial. So now I'm specifically in one project. Okay, now we're going to use Git. So we're going to type git init dot, which means we would like to initialize our current directory or dot as a GitHub Git repository. This will look like a .git / folder inside of our Python tutorial folder, your project folder, and it'll add version control and things like that to our new Python tutorial directory. All of our content, which is currently none, so we're going to change that and add some data. So you can see that as I initialize the repository, it just says we have made an empty repository. So to create some data, first, to keep everything organized, we're going to create a data folder. So again, mkdir for make directory and the word data. Okay, I'm going to enter. And I'm going to move into that directory, again with cd data. So now from within our data directory, we are going to download a sample data file, which is from a Davis Instruments Vantage Pro 2 instrument, which is currently at the CU Boulder East Campus and monitored by their Atmospheric and Oceanic Sciences Department. It's part of this larger CU Boulder weather network, but we're just going to take a single .txt file from a URL that points to it. So to do that, we type curl lowercase k, capital O, and then the link to our data, which instead of copying every single character, I'm just going to paste it in here. And someone from the Xdev team will post that in the chat, so you also can paste instead of, you know, potentially getting a spelling error and whatnot. So again, it's curl / lowercase k, capital 0, and then our site, which is sundowner.colorado.edu, etc. Okay, for me that only took a second to download. Hopefully you guys all have adequate internet. Sweet. And now we're going to use Git. First, we're going to check the status of our Git repository. So type Git Status. And this will show that we have a newly created directory. You can see we are on our branch master. There's been no commits, and there are no untracked files. But you do see it's actually a little hard to see. It's in red for me, this // which means that our current folder is untracked, which is our current data file. So every file working with in Git is considered untracked, modified, staged, and unmodified. And Git status tells us what we have and what to do with this. So we're going to add our untracked file from within our current folder with git add and then the name of our file. So first I'm going to do an ls to show you what this file is and that we have indeed downloaded it. And then git add wxobs 2017 0821.txt. Okay, to see what that did, we're going to do another git status to look to see if anything's changed. And yay, now we have a new file that is a change yet to be committed. Stages that haven't been committed yet, so we can commit them, which is kind of like, yes, I do want this change to be represented in my repository. So we do git commit -m for message, and then in quotes you put a commit message. This is good practice because a lot of times perhaps you were really confident in a change you wanted to make to your code, but it turned out you were wrong, and you know that last week your code worked, and so you want to go back to a previous version of your code. And instead of copy, pasting, and erasing and trying to keep track of everything in your head, you can look at the commit messages that'll tell you exactly what you did so you can figure out where you want to go. So I'm going to call this adding sample data file. And once again, we can look at git status to see what's happened. So we are clean, everything is up to date and has been shown within Git. And to see the changes we've made, we can type Git Log. So if you type that, you can see we've only made one commit with this long string of letters and numbers, which is why we create this message, because the message is a lot easier to remember than 26 FBE, etc. And that'll show you all the changes you've made. Okay, so wonderful. Our workspace is set up. Is everyone ready to create our first Python script?
Actually, I'm not sure anyone is. I've received a lot of feedback saying that a lot of people are lost at this point.
Okay. Do we know at what point? I can go back to the top.
There are people who are having really basic stuff like can't get curl to work, or their Git install isn't set up, or Conda's not working. I think for many of these issues, we may have to diagnose them after the tutorial.
Okay. I am sorry for those people. The few people I can see in my window have given me a thumbs up. So hopefully, you know, we can use the recording from this video and probably set up personal Zoom meetings to help out individual people that are struggling with their Conda install. Okay, well, I hope that we can fix those, but again, since this is a pretty short session, we are going to power through and then use it as a resource looking back. So we are going to move up outside of our data directory. So do cd ... to move up one. And then we are going to create a blank Python script. I'm going to call it mysci. So if you have Linux commands, you can do touch and then the name of your script that you would like to write. If you're on Windows, touch might not be recognized as an internal or external command. And if that's the case, you can run conda install m2-base to enable Unix commands, including touch. So I'll wait a minute to give anyone a chance to do this. Again, this is probably only if touch does not work. Okay, we are now going to edit this file that we just created. So you can use Nano or Vim or your favorite text editor. Again, if you're on Windows, you can probably just type mysci.py to open up the file in a notepad or your favorite editor. I prefer Nano, so I'll do nano mysci.py. And you see we've opened up the editor. Our first script, as in probably every other coding tutorial you've ever taken, is going to be a hello world. But hopefully that you'll see maybe some of the differences in Python between those other languages. So we do print and then open close parentheses. Print is your first ever Python function that you're learning. This will print out whatever we put inside of the parentheses. So I'm going to enter the string hello world. The string meaning that it's a series of characters in single or double quotes, up to you. And that's really all that we need on this file right now. And don't worry too much if your grammar or spelling is different. As long as you have the print, the parentheses, and the quotes. Okay, I'm going to exit the script editor, save my changes, and then to run the script, you type Python, and then the name of the script that you want to run with Python. And you can see what's been output is everything that was inside those quotes. Hello world. Okay, now we're going to edit the script to something more useful. So again, let's go inside the script editor. And I'm just going to delete this print statement and start blank from scratch to start writing a function, writing a script that takes a look at the header and the first 4 lines of our data file. So do that, we first do a hash that denotes a comment, something not read by the Python interpreter. It's just for us humans to read and to kind of organize and know what's going on in our code, and to help our future selves know what this next block of code is. I'm sure many of you have done something that wanted to change code that you wrote over a year ago and could not remember what is going on. So for that, Python comments are sometimes helpful. So we're going to describe what we're doing, which is reading the data file. And then we're going to create a variable. So to do that in Python, we type the name of what we want our variable to be, and then we set it equal to some value. Oh, actually, our first file variable is going to be called file name. And it is going to be equal to, again, a string, much like in our print statement, and then the path to our data. Then, to open the data file, we create a new variable that's data file equals open our file name, and then we specify this first argument is file name, the second argument is the string R, which means that we would like to read in this file. Sometimes you could do a W instead. That means you'd like to write to the file or to make changes to it. So that's all we have to do to open it. But then we want to print out the first few lines of it just to kind of see how our data is structured. So print, and then what we'll be printing is our data file, but with the first line read. And we're going to copy this exact same line 3 more times. Each time you call the read line function, our value data file has moved down 1 more line in the file. So we do this a second time, and we'll now print out the second line of our script and the third. And we're going to go ahead and print out the fourth. And then don't forget to close your file. This is important for memory issues. So I'm going to leave this up for another second before I exit the navigator or the editor. Okay, I'll move on. If anyone has any questions, who can post blocks of code in the chat. Save changes, our file name. Okay, so now again, we're going to test our script the same way we did before by typing Python and then mysci.py. And what was returned is the first few lines of our data file, the first 4 actually. And you can kind of see the names of the variables that are in here. We have various temperatures, wind directions, rain, date and time, and see that there's a lot going on. And we're gonna learn how to organize this into a way that's more useful soon. So we want to read in the whole data file, not just the header. So again, we're going to edit it with nano mysci.py. And we're going to change the script to read the whole file. So to do that, I'm going to take out these lines where we're just reading individual lines of the data file. And now I'm going to create a new variable called data, which equals datafile.read. So you can see that read is going to act a little bit differently than read line. Again, we close the data file, and then we're going to add a second comment and create a debug section of our script. In here, we're going to print out our data to make sure that we've read it and it looks how we expect. So now you'll notice that we printed the object data, the variable, and it looks a little different from the last print statement we did that had the strings around the word hello world. So to kind of emphasize the difference between these two types of print statements or types of inputs into print statements, we are going to print data as a string to kind of see what the difference between the two statements is. Okay, I'm going to exit the navigator now. And I'm going to run the script with Python mysci.py. Okay, you can see that we've printed lines and lines and lines of data. And we also just printed the word data. One more time, we are going to go into the Python script and use a slightly cleaner method, which is a context manager with. So I'm going to type nano mysci.py. And we're basically going to take these three lines of code from data file equals open to data file.close, and we're going to write them on 2 lines. So I'm going to delete these 3 lines. Okay, so with open, the function open, file name for reading, as before, as data file. So here we are opening it and setting it to the name data file. And then here we have to indent the next line. And I'm going to indent with 4 spaces. 1, 2, 3, 4. And I'm going to say data equals datafile.read. So this is, again, similar to the last method we used to open the data file, but we've now used with open. So the with statement, being a context manager, provides cleanup and assures that our data file is automatically closed once we finished reading it, which is very helpful and nice. The indentation of the next line is very important, as it shows that it's a piece of this with statement. And Python is very sensitive to white space. So it's important that you have a consistent number of spaces every time you do an indent. It's not recommended that you do a tab because in different editors, tabs are not consistent lengths. So it's pretty standard and best practice to do 4 spaces for your indent. And combined, these 2 lines again kind of translate into English as, with the data file opened, I'd like to read it and save the data to the variable data. And in our debug section, we no longer need to test what printing the string looks like. And we will just print the data to, again, show that it still works. Save changes and execute your script again with Python mysci.py. Should look the same as the first print statement from our last time executing the code. Okay, so now that we have our data printed, what type do you think the data is? So an object type in Python refers to a float, which is a decimal number, an integer, which is a non-decimal number, a string, which is a series of characters, or other types that you, the user, can create for other needs that'll maybe become clear as you learn more about Python. So everyone tape your guesses at what the data is. Maybe enter it in the chat if you want. And then we're going to make one last modification to our script to find out what the data type is.
Julia?
Yeah?
There's been one question, it seems like a good point. This is a question to interrupt on. One question was, what are the advantages of using each of the different methods to read the file, and disadvantages?
So we have done, I guess to summarize, 3 different methods. One using the function readLine. The advantage of that is that you'd be able to see the header of your function and know what each of these columns actually means. Because now that we've printed out the entire data file, you'd have to do a lot of scrolling to go see what the top is. So if you only want to look at the header, readLine's great. If you want to look at the whole function and you use readLine, you'd have to execute that every time you move down a line in the function, which, you know, there's ways to do that without typing it out 50 times, but it definitely isn't, I would say, the most intuitive way. It's nice to know there's a function, read, that just opens the entire file and reads the whole file. The advantage of the context manager, which is the third method we used, the with open, again, is that it automatically closes the data file for you afterwards. Is there anything on that that someone from the Xdev team would like to add?
No, I think that pretty much summarizes it. In general, best practice in Python recommends using the with context manager because it closes it for you after that block is complete. Many times there's not necessarily a problem if you use open and you don't close it explicitly, but if you don't do that, if you don't close it explicitly, you can run into problems in more complex code. So it's just general practice that with the context manager, it's a little bit safer.
Okay, I hope that answered your question. Okay, now that we want to know what this data type is, we are going to edit our script one more time. And instead of printing data, we're going to print the type of the data. I missed a parentheses there. So you can see that in Python, you can kind of chain commands. So first we're finding the type of data, and then we're going to print what type of data returned. So we kind of start internally and move outward, just like in I guess any like math operation from PEMDAS or whatever you used for order of operations in your high school or middle school algebra classes. So the only change we made is in our debug section, print, parentheses type, parentheses data, and then double close your parentheses. I'm going to exit, and I'm going to execute this. And we see that it is a string. Now, Python is a dynamically typed language, which means that you don't have to explicitly specify the data type when you name a variable. Python automatically figures it out by the nature of the data itself. So when it reads in this one file, it cannot automatically know that this 100.0 is a float, but W west southwest is a string. It currently just reads in the whole thing as a string, and then we'll have to go in and manipulate it based on the columns we want to get the data in a structure that's more useful. So next section, we're going to turn it into floats. We're going to organize it into a data dictionary, which is a great concept in Python. But until then, we're going to finish this session by cleaning up our code, by removing the debug section, and then making our final Git commits for today. So to do that, we open our script one more time. We go in and we delete our debug, since we do not need to save that. The only important thing to save is the actual opening of the file. I'm gonna leave this. Okay, we've cleaned up the code, and now we are going to make this represented in our Git repository. So the first thing we're gonna do is check the status of our Git repository. You can see that we have an untracked file, mysci.py. We're going to stage this file with git add. As you can see at the bottom, it says use git add to track the file. So git add mysci.py. Once again, we check the status, git status. You can see the file has been tracked. And we are going to make our Git commit as we did when we added the data file. So Git commit -m for message. And here a good message would be adding script file. Okay, so we have made one file has been changed. And then one more time, look at Git status, just to make sure that everything's cleaned up. And now that we have 2 commits, we can take a look at our Git log. So Git space log. You can do this. You can see that at the top is our most recent commit, adding script file. And then below it is our first commit, adding sample data. Eventually, though, as you've had a long project, you might have made many commits, and this could go off the screen and be kind of, I don't know, more information than you need and hard to see the information that you do need. So we type git log / one line to put each log on one line. When you do this, you can see that the commit number at the top has been reduced to the first 7 or so digits from the commit number, and that we just see the message. The date and time is no longer in our Git logs. That is displayed. So that concludes the first lesson of this virtual tutorial. It may not seem like we've gotten super far because we haven't actually done any analysis, but as you can see, setting everything up does take a little bit of time, and you've actually maybe learned deceptively a lot. We have created our directory, our conda environment, and our Git repository, downloaded a text file, and you've learned several Python commands. You learned open, read line, read, close, print, with, and you're now pretty familiar with the data type string. And we've also covered Git commands, initialize, status, add, commit, and log. So that is a lot to cover, and we don't want to move on to the next step until we've gone back and worked with everyone who had technical issues today, so that we can all be running in 2 weeks' time on the 28th. So we're going to pick up from here, and we're going to learn to manipulate our data structures. Thank you, everybody, and Now, if you have any questions specific to today, please put them in the chat.